Welcome back to VMware View Administration Training. Let's talk about installing View. In this lesson, we're going to talk about the system requirements you need for the different components of VMware View, including operating systems, databases, vSphere infrastructure, and some special caveats for different features. I'll also lay out some pieces that will need to be created within Active Directory. And then I'll talk about some of the options you have for your end users. We'll talk a little bit about the authority you can delegate within View, and we'll finish up by actually showing you the installation process. So let's dig in. The first component we'll discuss is the connection server. These requirements generally apply to all the different types of the management servers, including connection server, replica server, security server, and transfer server. For operating systems, if you want to go 32-bit, you'll need to use Windows Server 2003 or 2003 R2, both of which will require Service Pack 2. If you want to go 64-bit, your only choice is Windows 2008 R2. And if you want to provide PC over IP functionality to your internet-based clients, your security server is required to have Windows Server 2008 R2. For those 32-bit connection servers, you'll need to give them at least 2 gigs of RAM. But if you want to scale up over 50 desktops, you'll definitely want to consider having 6 gigs of RAM or more. If you're going with a 64-bit environment, each server will need about 4 gigs of RAM. And for scale, consider putting in 10 gigs of RAM. These minimum requirements will work well for a POC or a pilot infrastructure. As you scale into production, you'll definitely want to keep an eye on the RAM utilization and be prepared to increase it as necessary. Dual processors are recommended, but you can easily start with a lower processor. Just make sure it's at least a Pentium 4 with 2 GHz. The connection servers are usually deployed as virtual machines, which makes them very easy to scale up. So feel free to start smaller with the resources, but be prepared to scale them as needed. The virtualization software you're going to need is going to be vSphere 4, Update 2 or later, or vSphere 4.1. If you're still running a VI3 infrastructure, you'll need to use the latest updates for ESX and Virtual Center. If you're planning on using replica servers to provide high availability and load balancing across your connection servers, you need to make sure to place them together on a high-performance LAN. This is because the LDAP database that replicates between the servers needs to be able to replicate in real time. So it's not a good idea to place them in different sites across a low-speed WAN connection. If you plan on doing local mode desktops, you'll need a transfer server in your environment. Most of those requirements apply to it, but there are a few extra caveats for the transfer server. First of all, the transfer server must be run as a virtual machine, and it needs to be managed by the same vCenter that's going to manage your virtual desktops. This is so the vCenter server can manipulate the transfer server to help aid in distributing virtual desktops to your local mode clients. Make sure to configure your transfer server with a static IP address. When you create the virtual machine, make sure it has a LSI Logic Parallel SCSI controller. This is not the default for Windows 2008 virtual machine. When you install the transfer server, make sure not to install any other View Manager roles on that server. Later on in the lesson, I'll show you how to configure the transfer server repository. But for now, remember that the disk that holds this repository needs to have enough space to store all the Composer images that you're going to allow users to download. Part of the manipulation that the vCenter server will do with the transfer server is to actually mount the virtual disks from the desktops. In order to do this, any ESX host that the transfer server is on must have access to the same data store that the virtual desktops are on. This shouldn't be a big deal, since best practices dictate that all ESX hosts within a cluster see the same set of data stores. The final requirement for the transfer server is one you shouldn't have to do manually. When setting up the transfer server within the View Administrator, View and vCenter will set this virtual machine to a manual DRS mode, preventing any automatic vMotions of the VM. Next, some specific requirements for the View Composer functionality. Most importantly, Composer must be installed on the same server as vCenter. This means that the system requirements for Composer are a subset of those for vCenter. If you don't already have a vCenter and you're planning on implementing View sometime in the future, make sure that your vCenter is installed with these requirements in mind. So for vCenter 4.1, you need to make sure to use a 64-bit version of Windows 2008 or 2003. This, of course, is because vCenter 4.1 is a 64-bit only application. If you're using vCenter 4 Update 2, you can choose either a 64-bit version of 2008 or 32-bit version of 2003. Finally, if you're using Virtual Center 2.5 Update 6, you must use a Windows Server 2003 32-bit operating system. Composer has a database component that it uses. The SQL Server requirements for Composer are also a subset of those for Virtual Center, so there are many options of SQL Server you may choose, and several for Oracle as well. And finally, it is fully supported to use the same SQL Server instance as the vCenter database, though it is recommended to put it in its own database. Now, some of the features of Composer also have specific requirements. Some of those features do require vSphere mode be enabled. In order to enable vSphere mode, all the hosts in the cluster must be at least ESX4. These features include the utilization of local data stores, so you can store the linked clones on a local data store while the parent VM exists on a centralized data store. This feature allows you to use cheaper local storage instead of using more expensive SanDisks. Disposable data disks help to speed up the refresh operation of the View Composer desktop pool by placing all of the unnecessary data into a disk that can be easily deleted. When using vSphere mode, you'll be given the option to separate the different disks that make up a Composer-based desktop across different data stores. This can be very useful for tiering your disks to put the high I/O on higher-end disk and the low I/O disks onto lower-end disk. If your pool is enabled for vSphere mode, you'll be able to use hardware version 7 virtual machines for your parent image. You will also have the option of using sysprep instead of the quick prep option that Composer normally uses for the linked clones. This particular feature is only available when you're using at least vSphere 4.1 or later. In order to use the View agent, you need to use one of these operating systems. Since the agent goes on the virtual machine that the end user is going to connect to, all of the operating system versions are end-user focused, including Windows XP, Vista, and Windows 7, and the terminal server editions of 2003 and 2008 server. For your end-user devices, you'll need to use a desktop operating system, specifically Windows XP, Vista, and 7, or Mac OS X. If you decide to use thin clients, you'll need to make sure that they are in the thin client compatibility guide that VMware produces. If you want your users to have the ability to check out a desktop, you'll need to make sure that your end users are using a physical Windows system, and that the hardware that they are using is capable of storing that entire virtual machine and has the memory and CPU resources to run that virtual machine along with the operating system already installed on that device. If you want that virtual desktop to have the Aero interface within Windows 7, you'll need to make sure that this device has a fairly modern processor and video card. If you want to deploy 64-bit virtual desktops to local mode clients, you'll need to make sure that the end-user device has at least a Pentium 4 processor or an AMD 64-bit processor. Each of the protocols that View supports have specific requirements. As a reminder, View supports the PC over IP protocol, the RDP protocol, and the HP RGS protocol. For PC over IP, if you want to provide high-definition video to your end users, you'll need to make sure that the virtual machine has dual CPUs. Dual CPUs are also required for running full-screen 480p videos on Windows 7. When providing PC over IP connectivity, you'll need to make sure to give at least 768 megabytes of RAM to Windows XP, or at least 1 gig of RAM to Windows 7. These requirements are definitely on the low end, and most likely you'll have to deploy them with more RAM than this. Finally, the client device must have the SSE2 extensions on the processor. This will encompass most processors in the last 4 or 5 years. For RDP, you'll need to make sure that the client device has at least RDP version 6, which is already included in Windows Vista and Windows 7. RGS is not actually bundled with View, so you must go to HP in order to license it. And it only works with HP workstations, Blade PCs, and Blade workstations. so they're a very special use case. The RGS protocol was designed specifically for remote graphics rendering, and seems to have found the most popularity for engineering firms that use a lot of CAD designs. There are a few features within Vue that have specific requirements. Multimedia redirection, for example, requires that the client machine must be Windows XP or Vista, must be running Windows Media Player 10, and will only support MPEG-2, Windows Media Video, AVI, or WAV format. When using Adobe Flash Control on your pool, Flash has to be at least version 9 or 10, and using Internet Explorer, and in any case is not available for full screen mode. If you're deploying smart cards, you need to make sure the drivers for the smart card reader are installed on both the client and the virtual desktop. The key used to encrypt the card must use a size of at least 1024-bit or 2048-bit, and using PKS11 or Microsoft Crypto API. To properly set up Active Directory, you need to make sure that the Vue desktops are contained in the same domain or a domain with an equal trust as the connection server, since the connection server must be able to directly manipulate the virtual desktop and pass through authentication credentials. While most Vue components must be a part of the Active Directory domain, the security and transfer servers do not do any authentication of users directly, and therefore they can be left out of the domain. This is because they are specifically designed to be part of the DMZ, and as best practice you don't want your DMZ servers to be part of your Active Directory domain. It's highly recommended you create an OU specifically for the Vue desktops, so that group policies can be applied to the Vue desktops that you wouldn't want applied to any other machine. You also need to create dedicated OUs in groups if you want to have clients set up in kiosk mode. In order to ease the administration of Vue, you'll want to create groups that are based on pool and application access. These groups may already exist in your environment, since pool and applications are usually deployed based on job function. You'll need at least one service account for Vue to access vCenter. There are specific permissions within vCenter and Active Directory that you'll need to set up for service accounts for both Vue and Composer, but you can use one account for both of these services. I won't bore you with the details of what permissions are needed, because they're well documented in the Vue installation guide, which I'll display a link to later in the lesson. In order for the users to connect to their virtual desktops, you'll need to make sure they get added to the Remote Desktop Users group. The two most popular ways of doing this are either adding domain users to this group in the base image, or by using Active Directory group policy to apply these to the virtual desktops once they've been deployed. And finally, take advantage of administrative templates that are provided for Vue for use within group policies in Active Directory. VMware provides templates specifically for the connection servers, the client machines, and the Vue agent machines. Next, let's talk about client devices, the most popular of which are thin clients. These are small devices that run stripped-down versions of Linux or Windows. They're generally built with no moving parts to increase durability. They tend to have far less power than a traditional desktop, and are designed with very little disk space. Zero Client is a special type of thin client that has no operating system. Generally, they'll boot off the network to a management server, which will stream the desktop down to the device. I like to think of these devices as KVM extenders across the network. Another popular option is to repurpose PCs. This is a great way to save money on the initial Vue implementation. It's a great option for extending the life of devices you already own, but may not be capable of running the most modern operating systems. There are several third-party products available for repurposing a PC, but the idea is to simply lay down a stripped-down operating system that provides nothing more than the Vue client to the end user. Another great use case for Vue is enabling the bring your own PC concept. This could mean allowing your employees to acquire their own hardware and bring it in and work off that. You then provide them a Vue desktop with which they can access their Vue data and applications, thereby relieving your internal IT department from having to manage the client devices. And finally, let's discuss delegated authority. Delegated authority is role-based authorization within Vue. The role is simply a collection of privileges within the Vue administration console. You then grant Active Directory users or groups to one or more of these administrative roles. You can then arrange your desktop pools into different folders. You can then grant Active Directory users and groups specific roles to different folders. This allows you to create different groups that have access to different sets of virtual desktop pools, but not to others. Before we get into the demonstration, let's talk about the installation process. First step is to install the connection server and any replica servers you may want. You can then install View Composer on the Virtual Center server. And finally, tie the connection server, the composer, and Virtual Center servers together. After that, you can install and configure the security server and the transfer server. In order to create virtual desktop pools, you'll need to next install the agent in the parent VM. And finally, you can install the View client on the end user device, or put a thin client or zero client into place. So now to get into the demonstration. But before we start the installation, let's take a look at our Active Directory setup and review some of our prerequisites. So here you see we have 3 different groups created to represent our different groups of users, plus a group created to define who has administrative rights within View, and finally a group created to contain all the users that will be allowed access to View desktops. Next you can see we have a service account created for View to use. And finally we have a vDesktops OU created in which all of our virtual desktops will be created. This provides us the opportunity to apply group policy to only the virtual desktops and nothing else within our domain. So now let's switch over to our View connection server, which has already been added to the domain. So all we need to do is simply launch the View connection server installation. We get a security warning to open this file, which of course we want to happen. Now we have the View connection server installation wizard available to us. Start by clicking Next. Review some of the patents and click Next. Accept the license agreement and click Next. Now our first choice is where we would like to install the View connection server to. In our case, we're okay with the default, so we'll click Next. Now we get to choose which type of View server we would like to install. As discussed previously, the first server is always the standard server. After that, we create replica servers and point them to the original standard server. The security server is created in the DMZ and would allow internet-based clients to connect into your View infrastructure. The View transfer server is used for local mode clients to download their virtual machines onto their end user device. So, since we're starting with the very first server in our View infrastructure, we'll start with the View standard server and click Next. The installation wizard gives us the option of configuring Windows firewall ports automatically, which we'll allow it to do, so we'll click Next. Now clicking Install will allow the installation to proceed. As part of this installation, you can see that View is adding the Active Directory Lightweight Directory Services server role, which it uses to create the LDAP database that all of its data will be contained within. Now our installation is complete. You may notice a warning on the screen. This warning is due to the limited memory I was able to give to this virtual machine in my lab setup. When given the recommended amount of RAM for a View installation, this warning would not appear. We'll click Finish, and we're done. Now that View connection server has been installed, we can access the View Administrator console, which you'll see is actually just a web page hosted on this server. The certificate is a self-signed certificate, therefore we will get warnings about it. These warnings are okay, but in production you may consider having a trusted root authority provide you a certificate to use. View Administrator is Flash-based, so we do need to install the Flash player in order to use it. So we'll quickly go through the installation process for Adobe Flash. So now we have access to the View Administrator console. We'll log in using our administrator account. By default, any administrator on the View Connection server will become an administrator within View. Now there are many configuration items that are available to us, but for now we're going to leave those alone and address those in a different lesson. What's most important right now is to edit our license. So we'll enter our license key here. And you'll see now that our license expiration is now set to never, and we've enabled the View Composer and local mode features. And we'll come back to this configuration of View, but first let's get View Composer installed. So now install the View Composer functionality, which will allow us to use the linked clones with our View desktops. Composer is actually installed on our Virtual Center server, so let's flip over to that. So here you'll see my vCenter server, where we already have the View Composer installation on the desktop. So let's go ahead and open that up. Again, we get the security warning, which we can go ahead and run. Now this installation wizard is somewhat notorious for being slow to load, so have patience when installing View Composer. So now that the installation wizard is completely loaded, we can go ahead and click Next. Reviewing the patents, we'll click Next. We'll accept the license agreement and click Next. Now we have the option of choosing where to install View Composer 2 on the hard drive. We're good with the default, so we'll continue and click Next. View Composer requires its own database. This database can be shared in the same database instance as vCenter, and is also based on a 64-bit ODBC driver. Here you'll see I've already created a VMware View Composer DSN, so we'll use that. The recommendation for the database of View Composer is to use Windows Authentication. So in my case, we're going to use the administrator account. And we'll click Next. View Composer does provide a SOAP web services interface, and we have the option of choosing that particular port. We also have the option of using an existing SSL certificate or simply having Composer generate one of its own. In our case, both defaults are fine, so we'll go with that and click Next. And now we can kick off the actual installation by clicking Install. And now our installation is complete. We'll click Finish to close out the wizard. View Composer doesn't have a direct interface for managing it. Its sole purpose is to be a code base with which to interact between View and vCenter. So there's no further configuration we need to do with View Composer here. To perform the configuration of View Administrator, we're going to switch back to our View Connection server. But we can perform these steps from any computer that has access to the View Connection server via an HTTPS connection. So here we are back in our View Administrator console. We're going to start our View configuration with the very first section, the servers, where we'll add our vCenter server. We'll start by providing it the fully qualified domain name of the vCenter server. The username we're going to use is our View Service account. This account has been added to the local administrators group on the vCenter server. This is a prerequisite for the View Composer functionality. If you don't have View Composer in your environment, there are a defined set of permissions that your service account will need within vCenter. These are well documented within the View Administration Guide. Next, we can provide an optional description for our vCenter server. We can choose whether or not to have View connect to the vCenter server using SSL. This is a best practice we'll use in this environment. We can also set the port, which by default should be 443 on your vCenter server. The advanced section gives us the capability of defining the number of operations that can occur between View and vCenter. These can be applied for both provisioning and power operations. These can be used to throttle the amount of load that View can put on your vCenter server. But we'll be good with these defaults, so we'll continue with those. Next, we're going to enable View Composer functionality for this vCenter server. After clicking the checkbox, View will immediately check to make sure that the Composer functionality does exist on this vCenter server. Now that the little stopwatch indicator has disappeared, we know that View Composer has been found. And we can click this Add button to add a domain that View Composer will use for creating computer accounts for the desktops it creates. We can provide it a fully qualified domain name and a username that View Composer will use. I'm using the same account that View is using for View Composer as well. Many organizations choose to do this for two main reasons. First of all, it's simplicity for the environment. There's a single account that View uses, whether it's Composer or the connection server itself. Also, the permissions needed for both accounts are nearly identical. Now that we've added our domain, we can click OK to create this vCenter connection. And now you can see we have our vCenter server added in. We've already entered our product license, so we have nothing to change within this section. In the global settings section, we have several different options to set. The session timeout is the number of minutes in which an idle user can stay connected to their desktop. Once this timeout occurs, the client is disconnected from the desktop. Next, we could choose whether SSL is required for the client to connect to the View administrator. Checking the Reauthenticate Secure Tunnel Connections option will force users who experience a network interruption to re-enter their credentials in order to reconnect to their desktop. This is generally not used because you want users to automatically reconnect if they ever have a network interruption. Message Security Mode determines the level of security between the View Manager components. Disabled means that there will be no security applied between the different View Manager servers. Mixed means that it will be enabled but not enforced. And enabled will force signed messages to be sent between the View Manager components. Anything that's not signed will be rejected. Since we're on a secure internal network and feel confident in our edge security, we're going to stick with the default of disabled. Disabling single sign-on for local mode operations will force the user to log into View and then log into the desktop once it's connected. Normal behavior is for the View login to actually pass through to the Windows session and is therefore usually left unchecked. When enabling automatic status updates, View Manager will automatically update the top left section that you see in the grayed out background that provides status messages for the entire environment. While this is a good feature, it will prevent any timeouts for users logged into View Administrator. This is a potential security issue, but could also enhance the end user experience. The default is to leave this disabled, so we'll go with that setting. View gives us the capability to display a pre-login message after the users log into the View client. Typically, you see this as a terms of use legal message on what you can and can't do with this server connection. Finally, you can define a global message that will be sent to users when they are forced to log out during certain maintenance operations within Vue. You can also provide a timeout that gives the user a certain amount of time before that forced logoff will actually occur. Now that we're done setting these settings, we'll go ahead and click OK to apply them. The Registered Desktop Sources section will list out any non-virtual machine-based desktop sources that we have configured within Vue. Currently, we don't have anything configured, therefore you see zeros in both columns. The Administrators section gives us the ability to add or remove administrators, both as groups and as individuals. We're also able to define roles, which are simply groups of different permissions within the Vue administration. And finally, we can manage folders, which are groupings of desktop pools, where we can identify a user or group and an associated role. One use of folders is to limit the number of administrators that have access to modify a set of pools. In our scenario, for example, let's say that the kiosk that the customers are able to use, we want to limit to a certain number of administrators. We can come in here and create a folder, call it kiosks, click OK. We can now come in here and add a permission just to this kiosk section. And we'll search for a group called Kiosk Admins. And we'll give them an inventory administrator's role, which provides them the ability to manage the inventory, but not the pool itself. Now, any user who's added to the Kiosk Admins group will have the ability to go in and administrate the inventory. In the ThinApp configuration section, we have the ability to create repositories of ThinApp applications. Since we don't have any ThinApp applications, we'll skip this section for now. The event configuration section gives us the ability to create an event database. We'll address the event database in the monitoring lesson. Finally, we have our transfer server repository. This is where we'll set up our transfer server that can be used for our local mode desktops. Now that we've configured the basics of Vue Administrator, let's move on to the next section, installing the security server. So here's our Vue security server. It is currently not a member of our Active Directory domain. It exists within our DMZ zone. The installation, as you'll see, for the Vue security server is the exact same installer we used to install the Vue connection server. So let's start our installation. So now let's click Next and continue on with our installation. Click Next on the patent screen. We'll accept the license agreement and click Next. We're good with the default destination folder, so we'll click Next. Now here you see, again, we have our choice of which type of server we want to install. In this case, we want to install the security server, so we'll select that and click Next. Our main option when installing the security server is to identify an internal Vue connection server. Each security server can connect to only a single connection server, and not to a load balance pair or multiple connection servers. So keep this in mind when you want to provide high availability within your DMZ through the security appliance. properly pair our security server with our connection server, we must provide a password. So for that, we'll switch over to the View Connection server. So within View Administrator, we go to the View Configuration section and click on Servers. Then we come down here to the View Connection Server section. Select the connection server we wish to pair with. Drop down this More Commands button and select Specify Security Server Pairing Password. Now here we'll define what the password is. We'll use the password View Security with capital V and a capital S. And we'll leave the password timeout at the default value. Now we can switch back to our security server install, where we will type in the password that we just supplied. And we'll click Next. Since our security server exists in the DMZ zone and will be accessed by internet clients, we're provided the option of providing an external URL, since our internet clients most likely will not be able to resolve the actual name or IP address of the server. So we'll provide it with a URL that we want to use for our external clients. The PC over IP external URL is the URL that external clients using the PC over IP protocol will use. This particular URL must be provided as an IP address, so we'll provide it the external IP address that will be used to publish this View Security server to the internet. And now we can click Next. Again, we can allow the View Connection server installation to configure our Windows Firewall automatically, opening all the necessary ports. And clicking Install will now proceed with the installation process. And now our installation is complete, so we'll click Finish. There's no further configuration of the security server from here. So now we need to switch back to our View Administrator. Switching over to our View Administrator console, you can see the View Security server has already shown up after having automatically been refreshed. We can see its version, the fact that it's already enabled for PC over IP, and the connection server that it's associated with. Selecting this record and clicking the Edit button, we can see the server name, external URL, and PC over IP external URL that we provided during the installation have already been pre-populated for us. And that's all it takes to get a security server installed into your environment. So now we can move on to the next section, installing the transfer server. Remember that the transfer server is used by the local mode clients to access their desktops and download and upload the changes. So let's get into our final server installation. So here's our transfer server. Since we want this server to be accessible by external internet clients, we've left this off the domain, just like we did to our security server. You'll see here, again, the View Connection server is our installation medium. So we'll continue by double-clicking that. And now we find ourselves in a familiar place with the View Connection server installation wizard. We'll start by clicking Next. Click Next again through the patents. Accept the license agreement. And go with the default installation directory. This time we'll pick the last of the four and install the View Transfer server. Click Next. And the View Transfer server is based on an Apache installation to provide web connectivity. So we have a few answers that Apache needs. First is the network domain. Since we're going to be offering the service out on the internet, we'll use our external domain name. Next, we need to identify the server name that we'll use on the internet. We'll call this our view transfer. Finally, we'll identify an administrative email address. When we're done with those, we click Next. Since we're providing network access to the server, we'll once again allow the View Connection Server installation wizard to configure with the Windows firewall for us. And finally, we'll click Install. You'll see a warning here on the installation completed. This warning is due to the limited RAM I was able to provide to this virtual machine. In a production mode, when you provide the proper amount of RAM, you wouldn't see this warning. So let's finish up. Now you'll notice that the Apache Web Service is now running on the server. That'll complete the installation piece. Now we need to get back into View Administrator and complete the configuration. And now, back in View Administrator, we find ourselves on the Servers section once again. This time we need to scroll down where we can see the Transfer Servers section. We'll click Add. First, we must choose the vCenter server that is hosting our transfer server. Remember, one of the requirements of the transfer server is that it's managed by the same vCenter as the rest of our View desktops. We'll continue by clicking Next. Now we need to tell View exactly which virtual machine we want to add as View Transfer Server. We'll select View Transfer 01 and click Finish. Now we can see the View Transfer 01 has been added as a transfer server. The pending status means that View is working with vCenter to properly configure this virtual machine. So let's switch over and take a look at what vCenter is doing. Looking in the recent tasks pane within the vSphere client, we can see several tasks that have occurred against the View Transfer Server, all of which have been initiated by the View service. So let's walk through these all real quick. First off, it initiated a shutdown of the guest operating system. It then reconfigured the virtual machine. This reconfiguration was used to create additional SCSI devices within the virtual machine. During the transfer, View will mount the virtual machine's disk onto the View Transfer Server. Having multiple SCSI adapters allows for multiple transfers to occur at once. Next, it powered the virtual machine back on, followed by a reconfiguration of the cluster. View reconfigures the cluster in order to set the DRS automation level for the View Transfer Server to manual, so that DRS does not do automatic vMotions of this virtual machine. Next, you'll see a couple of changes to the virtual machine custom value, and one final reconfiguration of the virtual machine. So let's review all these changes directly. First, you'll notice the custom values that were added. Transfer server was locked on the specific date, and the fact that the VM is locked. Next, looking at the properties of the virtual machine, you'll see that 3 additional SCSI controllers have been added. Finally, let's review the DRS settings. Looking at the virtual machine options, you'll see the View Transfer Server has been set to a manual setting, thereby preventing any automated DRS functionality. So that's what View does to the View Transfer virtual machine. Let's switch back to the View Administrator. Now that we're back in the View Administrator, let's refresh our transfer servers, where we'll see that the status has been updated. Now it says Missing Transfer Server Repository. You'll notice that the transfer server repository is currently not configured. So let's go ahead and do that now. So the transfer server repository is used to store the View Composer images, providing easier access to the transfer server for sending to the View clients. No transfer server has been configured, so we'll click the Edit button to add one. Here you'll see we actually run into an error because we need to put the transfer server into maintenance mode, even though it's not been fully configured. So let's do that real quick. We'll have to switch back to the servers section. Select the View Transfer Server and click Enter Maintenance Mode. This warning simply states that while the transfer server is in maintenance mode, no transfers can occur. In order to make changes to the transfer server repository, all transfer servers must be placed into maintenance mode. Therefore, in order to make changes to the transfer repository, no users will be able to check in or check out their desktops. So let's go back into the transfer server repository. Clicking Edit again, you'll see we are now able to make modifications. Our choices are to use a network share or to use a local file system. Network share is generally recommended so that you can have multiple transfer servers that can share a single repository, providing quicker updates and less waste on your storage. For our network share, we're going to use our NAS server. Next, we'll provide the username for our NAS server. And our password. And finally, our domain. In my case, my NAS server is not on the domain. It's a separate network device. Therefore, we have a different domain and username. Once that's complete, we can click OK. And now we have a transfer server repository configured. Now for contents, we can publish virtual desktops, but currently we don't have any parent VMs defined within View Composer, so we can't do anything here right now. We'll come back to this. Now we can come back to our servers section, where you'll see the transfer server repository is now populated. So we can come in here and we can exit maintenance mode for our View Transfer Server 1. Yes, we do want to exit maintenance mode, so we'll click OK. The View Administrator console doesn't always refresh automatically, so we'll go ahead and manually refresh it. And now you can see that we are in a status of ready. Our View Transfer Server is configured and ready to be used by end users. So now we can move on to the next step, installing the agent in the parent VM. The View agent is installed on the parent virtual machine that will be the basis of all virtual desktops. So let's switch to that virtual machine right now. On our parent VM, you see a very basic installation of Windows XP. There are many best practices I've already completed on this virtual machine. We won't cover those right now, but they will be covered in a lesson specifically designed to talk about the virtual desktops. For now, we're mainly concerned with installing the agent, so let's go ahead and do that. We'll click Next now that the View Agent installer has completely loaded. Click Next on the patent listings. We'll accept the license agreement and click Next. Now we're given several choices as to what we're going to actually install. USB redirection is a feature that allows USB devices attached to the client device to automatically be redirected to the virtual desktop. This redirection can be disabled here if you don't want it to occur, but it can also be managed through group policy. So we'll go ahead and install it. To support Composer-based pools, we'll need the View Composer agent. Virtual printing is a feature that allows end users to use their local or network-based printers within their View desktop using a universal print driver. It also provides the feature of data compression for print jobs that need to cross the network to get to the printer. The PC over IP server is the software that allows a View client to connect via the PC over IP protocol to their virtual desktop. And finally, the PC over IP smart card support. This isn't a functionality we'll need here, but if you were wanting to support the smart card functionality and the PC over IP protocol, you would want to enable this. So now we have our features selected, we'll click Next and kick off the installation process by clicking Install. And now our installation is complete. We must reboot the virtual machine. So go ahead and let this reboot complete, and we can move on to our next section. Now the installation of the agent doesn't require any further configuration. It simply needs to be there before we create any desktop pools. So now we can move on to the next section, installing the Windows-based client. This machine will represent our end user device. Whether this device was brought into your environment by an employee, a customer, or a contractor, you may not want to provide them full access to your network. Providing them a virtual desktop in a centralized location may be a better alternative. This machine could also represent an employee working from home. Virtual desktops provide them an easy access internally without exposing your network. Either way, the easiest way to provide them the View client is to have them access the View connection server or security server directly. As you can see here, we can simply choose which client we want, and it will download. In this case, we're going to go ahead and use the View client with local mode, so we can test out that functionality as well. So now we can go through this wizard to install the View client. Go ahead and click Next on the patents. We'll once again accept our license agreement. At this point, we're able to choose the features that we'll install with the View client. USB redirection allows USB devices on the client device to automatically be redirected to the virtual desktop. View client with local mode allows the end user to download the virtual machine onto their device and execute it locally. Login as current user provides single sign-on capability when running the View client on a device that is already part of the domain. We also have the option to change the installation directory, but we're good with the default there, so we're going to leave that one alone. And we'll click Next. Next, we're given the opportunity to define a default View connection server. If the end user device happens to be a member of the domain, this value can be set through group policy. Most end users will end up using the same View connection server every time they connect, so we'll go ahead and fill in a default for this installation. And then we'll click Next. Next, we're given some options for the Login as a current user functionality. First of all, we can choose whether or not to even show it in the connection dialog. We'll leave this one enabled. Next, we can define whether or not it's the default option. In this case, we will not, because this device is not currently a member of the domain. We'll click Next to continue into the shortcuts, where we're given the option of creating shortcuts for the desktop and for the Start menu. We'll leave those both enabled. And finally, we can click Install. Our installation is now complete. Now, since we selected the USB redirection feature, drivers were installed on this device, so we must restart the computer before we can use it. We'll go ahead and let this restart and come back later after we've created some pools. So that wraps up our installation of the Windows client. and our demonstration of the installation of the different components of Vue. I highly recommend reviewing both of these documents before installing any Vue components within your infrastructure. So this lesson covered an awful lot of information. We started by reviewing some of the system's requirements for the hardware, operating system, databases, vSphere versions needed to support our Vue infrastructure. We also discussed some features that have specific requirements, like the Vue Transfer Server and the Vue Composer functionality. After that, we covered some of the requirements you need within Active Directory, including OU structure and accounts. We discussed some of the client devices and options you have for your end-user devices. I also gave you an overview of Vue's role-based security mechanisms and how you can delegate administrative control within Vue. And finally, I spent quite a bit of time showing you the installation of the different components of Vue, including the connection server, the security server, the transfer server, Vue Composer, the Vue agent in the parent VM, and the Vue client on the end-user device. Not all items have been configured at this point, but we'll get to those in other lessons. Thanks for sticking with me through this lesson. I hope you gained something from it, and feel comfortable with installing Vue on your own now.